بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف المرسلين سيدنا محمد عليه الصلاة والسلام. أفتتح بتحية الإسلام وتحية الإسلام، فالسلام عليكم ورحمة الله تعالى وبركاته. First of all, we would like to thank the jury members for accepting the evaluation of our work. Also, we would like all the audience thank you for attendance. Today we are present our work entitled and comparing static renewable energy resources of important optimal power flow solutions with the application green wave optimization GWO. It is presented by Nawal TALEB and Bashir bin Chouati and Professor Shteh Saleha. This presentation work is organized in this way. First, we start with the introduction about the problematic and optimal power flow. Then we give the problem formulation about optimal power flow in single and multi-objective. After that, mathematical models. Then optimization method. Green-Wolf optimization is a novel, natural and speed meta-heuristic algorithm. Before the last, simulation results and execution. Finally, we conclude our work with the some perspectives. The introduction. In this study, the electrical network consists of the conventional fossil fuel generators with the integration of the intermittent generation technologies based on renewable energy resources like wind power or solar photovoltaic PV or static power output by using an optimal power flow problem that represented various operating equipments such as minimize of the reproduction, field cost and perceiving generation emission at the lowest levels is structurally. In overview of the application green wave optimization algorithm which solves the OPF problem with renewable energy. Next, from the objective OPF analysis, first, to find the optimal solution is very important for power system operating with the static operation, constant planning and energy management. Second, the application green wave optimization algorithm which solves the OPF problem with the renewable energy. That gives optimal results to effective or network constraints. Third, the intermittent combination of the solar exacerbates the complexity of the problem. Move the next. Problem formulation. The OPF is mathematically represented as the mean and subject to. And from the multi-objective problem to minimize, the problem can be defined as flows, mean, max, and the subject to. Next, the constraints. The transmission system has several constraints which can be categorized as follows this equation. And from the n-quarterly constraints can be classified as follows from the function. Move the next. Mathematical models. Modeling of the cost, the terminal power generators equipment, the relationship between is expressed by the sum resources, this equation. And from emission and carbon tax, this equation. And this equation from emission plus carbon tax. The cost of emission is dollar in hour is represented as the mini costs compared are the calculated using this equation. Next, mathematical models. Modeling directory cost of the solar PV. The directory cost function of the solar PV in the terminus of scheduled power is valuing as this equation. And the solar photovoltaic power model this equation. Log normally distribution is defined as equation. and from the output power of the solar PV is a fraction of the solar is given by this equation. This figure represented the solar represented the solar irradiance distribution A and the ready power distribution of the solar PV B. Next, optimization method. This diagram from the classification of the case optimization space. In optimization methods which choose the meta heuristic. Next, this diagram from the classification of the meta heuristic algorithm divided in two parties, the global search and the local search. We choose the global search, exactly the Swearingen-based method. We are interested by the gray-wolf optimism. Move the next. The many equation from the gray-wolf optimization. First, the basic gray-wolf optimization, this equation, and for the spare updating position, and from the search space arrayed in the solution. Next, the basic working of the GW algorithm. The social hierarchy for the GW algorithm, this figure from the social hierarchy for the GW algorithm. Move the next. The first space has been applied to solve test system of the OPF problem. This figure from the cost dollar an hour, the convergence recovery of the case, and from the P losses, and from the emission, and finally with the multi-objective, the cost plus VPO. Move the next. Simulation results and desiccation. This the figure from the single and line diagram of the 13 best test networks. Case 1, minimization of the generation cost. The power generation plan is optimized for all thermal and renewable energy generators to minimize the total power generated costs of it. The minimum cost of the generating electricity that can be achieved using the power generation plan listed in the table is the $7,1807 in hour. From the case 2, minimize of generation case with the carbon tax. The study minimized total power generation costs, including carbon tax on emission from conventional coal-fired power plants to be minimized. The carbon tax rate tax is supported to be $20 in time. Move the next. This is the table from the optimal parameter using for optimization case studies modified A3 13 best system with comparison of the case 1 and case 2, exactly the total cost dollar in hour, the case 1 and other the case 2. Move the next. The table from the comparison obtained resulted the case 1 using in the study, and other from the case 2. This is the different. Move the next. Before the last conclusion, first, the GW algorithm has been implemented to solve the problem of the OPF with the static solar power in the network. Second, the GWO algorithm is evaluated to compare the effectiveness of methods by considering the total generation cost minimizing. In addition, this study has investigated an enhanced and effective variation of minimized total generation cost in the system. And the perspective it is investigate new procedures for scheduling the renewable energy using with a variable review value strategy in the form of the batteries or the pumped hydro in the networks with the 4 systems with large number of the best standard system. Thank you for attention.